All right, they're about to take us on the factory tour. I got to get back in there because they're actually waiting on me to get started with this tour. So let's get back in there. I'll flip the camera around and I'll show you what this place looks like. This is going to be the cool video.
Floor, and as well as Aaron, you can stop and ask him a question. He can explain that question to the rest of the group because somebody else might have the same question you have. When you get into the factory, there are invisible barriers, like on machines, where it looks like you can reach in and touch the stuff. As soon as you do, a laser barrier is broken and it shuts down production. So feel free to get close and look at it, but if it stops and it starts beeping and flashing red lights at you, it's because you got a little too close, but that's okay. That being said, let's get you guys a pair of safety glasses here. Grab yourself a pair of headphones, and then he's gonna hand you a black little receiver.
90 headphones.
Thanks for your safety glasses. Oh, thank you very much. Oh, no, this is the one I don't like. These are the straight ones. Okay. You guys hear me? Okay? Good to go? Are we live? G201, you guys are good? Yeah? You good? You're not good? You're on the right channel? Do you have the volume button on there? Is your volume button up? Now you're good? Some people turn them down intentionally so they don't have to hear me. Anyway, it's all good. Hey, welcome to Hunter. My name is Steve Hopeland. I'm the product manager for all of our rotors and our valves. And I've been at Hunter for about 33 years. And so lucky for me, I get to give you all a tour of Hunter San Marcos today, or at least here in this building. And then Aaron will take over and tour other parts and share other parts as well. Here on the back wall behind us is a plaque in honor of our founder, Ed Hunter, and his son Paul Hunter. A long, long time ago, when I first started Hunter in 1990, we would come out here with customer tours, and I worked for Hunter in Florida, and we'd go visit Ed right behind the desk, or right behind where this old time poster is at. And we'd go visit Ed and talk about products and things like that. And so this is the original front door entrance. When Hunter first started, his wife Frances used to work at the front desk, and then Ed was right behind there at his wrapping paper. I'm going to walk around out on the floor. Your ticket to go to wherever you want to go is your safety glasses. Just make sure you've got glasses on. As we're walking around, you feel free to talk to whoever you want to talk to, go wherever you want to do, and take whatever pictures you'd like. We'll try to answer all the questions that you have to the best of our ability, and if there's something that we don't know the answer to, both Aaron and I will likely make up the answer, and it'll sound very, very believable. But we'll get to the right answer at the end anyway. So nonetheless, so let's walk through this way. Let's head this way. Here on the right is a plaque that shows some of Ed Hunter's patents that he has. Since he has passed away and got out of the design business, we've got tons and tons of other engineers that file for many, many patents on a regular basis. And I don't even know how the total patent count that we have left to be 155. Thank you. You're welcome. Every single part that we produce. Now there's a handful that we don't make, but it's pretty small. We'll talk about a few of those parts as we go through. But for the most part, all the parts that we have are all built here on site with molds that are designed and built specifically at Hunter. So just to talk about the molding process quickly, how molds works is the mold is a big block of steel in the press right here. Beads of plastic come from upstairs or from our silos. The beads of plastic come in this hopper right here. They go into the horizontal heater barrel underneath the steel shroud here. That material is liquefied to about 500 degrees, and it's like hot honey. At that point, we squeeze it inside that mold at about 5,000 psi, very much like a high-speed, high-precision waffle maker. Just like if the waffle maker were closed, you squeeze in the batter, cook the waffle, open it up, and the waffle drops out. And that's what happens here at Hunter hundreds of thousands of times in this building and in the building that we go to down the street from the That big block of steel is like an engine block. It's got water jackets all around it. Water circulates through that block of steel, cools the block of steel, hardens the plastic, and then the mold opens and the part drops out. Some parts will recognize as we walk around, others we won't recognize. This particular mold is making looks like a PVP Ultra novel housing, I think. Flat top. As we walk through these parts, then you'll see some of those parts being assembled back on the other end. We're going to go to the molded part. So in this case, what's happening is we've got 3 of these heater barrels that are shooting liquid plastic. 2 barrels are shooting blue material, and 1 barrel is shooting gray material. I'm going to step a little further down. Same thing is happening here at the second machine. Feel free to pick up a nozzle rack if you'd like. Be careful, there's a little bit warm, not terribly hot.
That's a fresh one. Still wobbly.
And then there's a part at the end of every one of those tips. So just pretend like this is an irrigation lateral. You put water in the big pipe that splits off the smaller pipe and you center feed, and then you got sprinklers at each of those points. So you want to center feed all of those parts to make sure that every part has the exact same injection pressure, so make sure it fills at the same time. Wrapped in here, some of these parts would look like this. They'll be in there like this. And so this is the part that we want. This is the part that we do not. Here at Hunter, we recycle 100% of all of our material. Much of the material is recycled, reground, and mixed back into the part. However, many of our parts, like this big part called the build gear, are so critical in size that we have to use only virgin material. Once we liquefy the piece of material, liquefy it, squeeze it in, cool it down, and make a part, if we do that again, if we regrind this and make another part again, it just doesn't come out the same. It's kind of like eating spaghetti after the first time. It just doesn't taste the same like it did for the first time, maybe 2. So we got to be careful with that. So we're very critical inside. We're going to go to the QC lab after this. We're measuring parts there down to the tenths of the thousandths of an inch. Just to put that in perspective, the thousandths of an inch, we pull the hair, the thousandths of an inch is about the diameter of that hair. So a third of the hair is thousandths, and we're measuring to the tenth of the thousandth of an inch. So we're taking that 1/3 of the hair, slicing it 10 more times, and then measuring that criticalness on our part. We're not making the switch opposite, but we're not far away. It's pretty close to the part's got to work right, because we know from history that that part is out of size column. Then by the time it gets all the way through to the other end, where it gets assembled, it's not going to mate well with the other parts, and it's going to look problem. But it's going to fail in the field. That causes problems for all of you, and that's what we have to do. Circulate around the molding machine and check the stuff out. Now what happens is we have robotic arms to reach inside and grab out the runner. And then push that runner back to the regrinder, round back up, shot back up there, and go back and put back into the regrinder. Turning this like hardest is great. All we want is great to begin. time because the beef will be all on the floor. But I'll just leave it here and we'll maybe Aaron can come up and front and grab a sample of the bag. Aaron. So I'm going to leave the bag here with Aaron. This is the sample of the material with the blue dots. The way it works is the blue dots, when they get hot, they expand. And it colors all the material. So this is the material that would make blue VCP nozzles. So Aaron will hold this bag of material and you can fondle it or whatever you'd like to do. That's just so fun. Make small parts or make big parts. These have to be little teeny gears that are going to be used in the reverser frame of the PGP back on the sub-assembly machine. But these are pretty small little teeth, and we've got a kind of a small little mold in there, but it's punching out those nozzles and reaches in and grabs that runner. In this case, that runner will probably not get reground to make this part because that part is so critical in size that it won't make the same part quality the next time. So that part will go out. That runner will get scratched. I'm going to step all the way in. Let me grab Doug. So that we're walking on the Doug. Technicians, or there's a number of them, these quality control technicians go to the floor and they regularly collect samples from those molds that are running. They get one sample from every cavity and then they bring that sample back to the machines. In this case it's an automatic machine where it's visually measured with the machine.
Yeah, in this case it's doing a mechanical measurement with a touch probe. But it'll also do a focal plane measurement, or optical scan.
So every part on the engineering drawing, it says how often it should be measured, and it says what critical dimensions need to be measured. So this particular part, I'm not sure how many critical dimensions are on there. Doug, do you happen to know that?
There's a lot.
A critical dimension is a dimension that engineering, well, there may be 100 different critical, maybe 100 dimensions on this part that could be measured. But engineering has determined, along with quality, that maybe there's 10 that are really critical. If you measure those 10, then that's a really good indicator that part is going to be good to go.
Yeah.
And so as the part is designed, as the tool is built, as the R&D mold gets producing parts, and as the first parts come off, all of those critical dimensions are checked to make sure that the parts that we're making are good. Let's say that the frequency of checking here is every 4 hours. They'll go out to the floor every 4 hours, collect a sample of parts, bring them back and measure it. Then it tracks in the computer system exactly how that thing's tracking on size. Now they're not here to catch the quality of every single part. They're looking for trends. And so if they've got the upper spec and the lower spec, and typically those lines are about how far, what's the upper and lower spec of a dimension?
We're like plus or minus 2/10.
Plus or minus 2 thou or 2/10?
2 thou.
2 thou. So plus or minus 2 thousandths of an inch.
About a tenth of a hair.
About
1/10 of a hair.
not much, just a little bit. So they're looking to see what that trend line is happening. If they measure parts from right now, let's say, and the parts are out of spec, they look back at the previous one and go, they were in spec before. So they'll quarantine all of those recent parts for the last 4 hours, and they'll red tag the mold. But first, before they completely shut it off, they'll get with the molding technicians, have them come by. Maybe the water temperature changed or the injection pressure changed. Something changed to change that part quality, to change that size from 4 hours ago to today. They'll try to get it tuned up, try to get it running. They'll scrap the parts from that last good window until this now bad window. If they can't get the mold repaired, then they red tag it, send it across the street, for our own tooling shop repairs that mold and gets it back into operation. When it comes back here, the first mold, the first time back, it needs to get requalified in quality before it's ready to run, and then it's ready to be pulled off the shelf.
To expand on what his explanation is, when the quality is really starts at design, and the design engineers, the manufacturing engineers, process engineers are all really what makes Hunter quality special. We measure it here and we track it, but the design bears the quality. And what happens is they make a spec, it's like this, these spec limits, upper and lower spec. And then we have statistical control limits, which are here, that are inside the spec limits. And we determine that using statistical tools. We look at the whole distribution and how much variation is, and those guys design a process for us here that will produce 0 defects. If we had to inspect every part and say, here's a good one, here's, ship it, here's a bad one, eventually we would ship bad ones. Human error is human error. So we qualify a process statistically to be capable of producing 0 defects. So what we're looking for here is change, not necessarily spec violations, but changes to the control limits, which are typically tighter, or almost always tighter than the specs. So that's what we do. And if anybody in the world tells you they inspect quality into the parts, it's an impossibility. I mean, I'd need a building this size full of inspectors to do that. So we make a very tight spec and a tight controlled scenario to make sure that the parts are all conforming.
In 2 minutes or less, tell us about some of the equipment here. We got to run over and check out some PGP assembly. So.
Yeah, we have these automated inspection devices here, but we also use some stuff. She's not here today. She has COVID, but I have an engineer. If you guys want to gather around a little bit, I have an engineer that works for me that's certified and qualified to use the analytical equipment at UCSD down the street here. And she can go down there, and we share a lab with the nano engineering department. They have a microanalytical lab. So we use their scanning electron microscope, for example, and several other of their lab equipment. We also use a FTIR, which we have here on site. And we're interested in qualifying now a new FTIR, by the way, is an acronym for Fourier Transformed Infrared. It's a way of looking at the infrared spectrum to determine what material you're looking at, and it's a very accurate technique. We're also exploring CT scanners. These are about 450,000 a piece, and what we can do with the CT scanners, we can take a 3-dimensional X-ray and examine parts in shapes and dimensions that are even impossible to measure with this equipment. And we can literally take a CAD drawing and superimpose it over a scan and see little variations in compliance. So this is probably one of the things that we'll do in the future. The beauty of X-ray is we can look at an assembly without, if there's a defect here, we can see it without destroying the evidence or taking something apart. We can look at it in assembly. So this is some of the future.
Before we move on, we'd love to stay all day and hear about quality, but we have to run.
Yep. Thank you so much. Enjoy your day.
Well, that was pretty cool. Let's see what they got next.
PGP assembly area. We've got 2 fully automated machines for PGPs and PGP ultras together. That part, there you are, that part that you picked up back there at the mold machine, this is where that part gets used. So it goes right here into the feeder bowl, and you can see as it comes around the vibratory bowl, it gets put onto the conveyor track right here. And then we put on a couple of gears, put on a pinion shaft, a little grease in there, and put a gearbox cover in the top. All of these covered for you will be connected to the gear. The benefit is that we have all the things to put together our product, and we take the surface over, just a basic surface, so we can you'll be the first one to see it. But did you know that the PGP body cap has a date code on it as well? And you know how to read the date code on that? So the date code on the current PGP body cap is a number, and then it's got 1 dot, 2 dots, 3 dots, and 4 dots. So the symbols to show what quarter that's made in. And so what Sam Rogers is working on here with the molding guys is a new date code wheel. It's right over here, and it's a wheel that's pointed to the number, so it's got the year, and then
It points to the month and it has the year printed on it.
this is for the young eyes. So old guys might need to bypass this. It's got the year, and then the arrow points to the month. So we'll just pass it to you first, and you can pass it around. Sam Rogers is going to hang out right here and make sure it gets collected again. But we're gonna go check out this PGP nozzle assembly. So come on over here when we get.
Can we make an example of the invisible barrier? Video purposes? Yeah, we don't want to stop hunting. Well, that's what happens when you do that.
You do not get an idea. This gearbox right here is the same gearbox that's coming off of that machine, that very first sub-assembly machine that we stopped and looked at. So the part that you picked up is this bottom portion right here. And now it's all built together with gears on the inside. It's got a pinion shaft. It's going to get a turbine wheel. That turbine wheel is going to be powered by incoming water or air and put power out to the gears up on top and go all the way through and make that head rotate. This machine that we're standing in the middle of right now is not a fully automated machine. All we do is feed it raw parts, and it makes the entire sprinkler start to finish, and they come out at the end of the line right over here with the lady with the green and yellow vest. Yeah, so what happens here, we're going to walk around it too, just to show you, but what happens here is it starts with the gearbox goes down the left side of the machine, comes back on the other side, comes back, and that's machine number 1. Goes overhead to machine number 2, where it gets the variable stator and a filter screen, goes up the elevator over to machine number 3, where it gets a spring seat, riser seal, body cap, nozzle housing, rubber cover, all pressed together. Then it goes up overhead. Machine number 4, where it drops into a body, tightened up, air pressure on the machine, go out to the box, and then the box goes down, and this nozzle back to the top. This machine is one of about 250,000 PGPs, some model every single week. In addition to what we're making down in Mexico. The PGP for us is a huge seller, and we get two fully automated machines to do this. Right now, I don't think we're working 24 hours a day. It's surprising if we are. But during the height of COVID, we were running 24 hours a day, 6 days a week. We allowed 1 day a week for equipment repair, maintenance, preventive maintenance, and also we ran 7 days a week. We run ourselves out of parts, and so we can't run so much and run ourselves out of parts. So the molded part supply has got to keep up with the build. So we can't outstrip that. We're no different than you guys. The exact same way. We can't put it in faster than get the supply. So lucky for us now, the supply chain has turned around. The raw materials are a lot more accessible, and we can have a better control over our parts supply and make all that work. This is one jumbo large machine all around. The machine on the other side makes the risers, and then it comes off the final assembly machine here. I'm going to step over here and check out some air tests, and we'll go. What's our shift? We're running 5 days a week.
7 days a week.
Say it was not 7 days. So she's going to run 24 hours a day, 6 days a week right now. So right now, we gotta get the sprinters good. We've got a lot of sprinters in stock, so we anticipate big sales as we come on the sprint as well. So here you'll see right here. The risers are air tested on the line before they get to this point. But after they get to this point, they're popped up on air. You look at the very back here. Straight in the back, they're popped up 6 at a time. And those little drippers drip the nozzle housing. And it measures how many degrees it is. That machine back there knows how strong and how fast that nozzle housing is being spun. If there's a liquid or if one doesn't hold it, then it kicks off secondary reaction. Test it every
'em. I won't reach into it. Look at this, all EV parking right in front of Hunter. And it's all being powered by those solar panels.
They really do care about the environment around here, huh?
Welcome to our MP Rotator building. My name is Kelsey Jacquard. I'm the product manager for MP Rotators and Sprays. So again, I know you guys are here for commercial control expert training, but just want to show you some of what we do here at Hunter Industries. We have some pretty cool automation that we've got going on for MP Rotators. So we'll take a look at that together. But first, while it's quiet, because it's pretty loud out on the production floor, we're just gonna answer any questions you guys might have, talk a little bit about how an MP rotator works, talk about an MP rotator at all if you're not familiar with it. Yeah, and just take a little quiet opportunity real quick. So, are you guys very familiar with MP rotator nozzles? Get some head nods. We love them. We love you. So yeah, thanks.
We love those nozzles.
Thanks. We love them here too. They all are made here in this building, and we've just been growing capacity for the last, I don't know, 15 years almost now that we've had it. We acquired the MP rotator from Nelson Walla Walla in 2007. Came with a select amount of nozzles at the time, and we pretty much took that design and ran with it, added more nozzle options to it, and increased capacity dramatically. So I mean, when we first got it, Nelson was selling maybe 1 million of these a year, and we're up to like 14 million a year at this point.
Wow.
It's wild, yeah. So our engineering team has done a really nice job. So for those of you who might not be familiar, MP rotators are they have a lot of names. So high efficiency, rotary, MSMT, multi-stream, multi-trajectory nozzle. There's a lot of names to it. And just to compare it to a typical spray nozzle that just puts out usually a decent amount of water over a targeted amount of space, those are made out of 3 to 4 different parts. MP rotators are made out of 20 parts, all put together using automation. 21 parts if you ask engineering, but I used to be, I'm not anymore, so now I say 20. We can't draw all 21, so if we can't draw it, they don't count. But we got 20 solid parts to the MP rotator. They're also all shown right here on this table. And then there's silicone that's injected into what we call the rotor piece. So this is the rotor. And silicone's injected into that to help with the slow speed of rotation that we like to see from an MP rotator nozzle. So the way the MP works is water flows through the bottom of it, obviously. So we've got a removable filter here. Water flows through. We have a few different places that are really critical to the MP rotator. So the main one is the nozzle and deflector. And you'll see they're pretty big on this screen, or on that picture. They're super tiny on here. So we've got some parts these parts are plus or minus 0.5 of an inch on some of them. It's pretty wild. And so as you adjust your arc, the nozzle and deflector adjust the opening inside, and that's what maintains your matched precipitation. If you open the arc or close the arc, basically the orifice inside opens and closes as well. Also, we have our collar and our throttle. So as you adjust the radius on the top of the MP rotator, this opens and closes an opening on the inside here too, also maintaining matched precipitation for the radius adjustment of the MP rotator. So it's pretty cool to see that, and they're really, really small. So then water is gonna keep on flowing through. It's gonna hit the grooves of what we call the rotor, and it's gonna create drive, and it's gonna make that MP wanna spin really fast. But inside we have silicone along with this brass stator up here, and that dampens that speed of rotation so that we get that nice slow speed that we're used to seeing from an MP. And we actually want to see a slow speed of rotation. It's something that we check here on the line. You'll see that because if you have too fast of a speed of rotation, you start to get whipping. So the streams can't go their full distance anymore, giving you that full coverage. You start to see whipping. And so if you're running an MP maybe at higher pressures, you might see that. There's some competitor product out there that spins really fast. You'll notice that those whip. But with the MP rotator, we try to maintain that nice slow speed of rotation. So that's how it works. Any questions on that? So if you ever have an MP or anything that's maybe rotating slower than you would expect, everything is driven by the flow. And your flow is partially driven also by your pressure, right? So checking pressure, making sure you're getting a full flow through the MP, making sure no one adjusted that radius down. Sometimes that happens. We can't control everything that happens on our site. And so I've had some come back that the radius had been turned down and the guy didn't think that that had happened, but obviously you're not there staring at that one sprinkler all the time. So things can happen. The arc can't adjust unless the MP's actually popped up and operating. So in that regard, your arc isn't gonna come out of adjustment, but somebody with a screwdriver can come play around with it for sure. And then we've got all of our MPs lined up in the back. So we'll just talk briefly about these and then we'll go out on the production line. So when we acquired the MP rotator, it's a little dark in here, I guess I should have turned on a light. It started with the MP 1000, 2000, and 3000, as well as some of our side strip models. And these, thank you, Justin. These have that nice slow precip rate of 0.4 inches per hour. So for reference, a typical spray nozzle puts water down at about 1.6 inches per hour. For folks who are more water conscious, I know some areas still don't care that much yet, and that's totally fine. Here on the West Coast, we're starting to care quite a lot. We're trying to match the precipitation rate to the soil infiltration rate, right? So we're trying to eliminate runoff. So with the MP, our standard MP rotators with that 0.4 inch per hour precip rate, you're almost guaranteed not to have a runoff situation. It can be applied onto pretty tight clay soils, and you're gonna minimize any runoff with that because you're putting water down really slowly. We have since added the MP 3500, so now we can go from 8 feet at the lowest with the 1000 up to 35 feet, all with that same matched precipitation. So that's really nice for new installations, folks with weird squiggly designs on their landscapes. Nothing's ever a perfect square, is it? You can mix and match but have that same matched precipitation, so that's really awesome. You also have a lot of options too if available pressure has dropped. That's something that we're seeing with more and more construction going in. The available pressure has dropped to some of the landscapes that were spray nozzles before. You've got a lot of flow going through a spray nozzle. So if you reduce that flow using an MP rotator, because you've reduced your precip rate, you've reduced your flow, your pressure loss through the system also drops. So your actual available pressure at the heads can go up. So these are a really nice troubleshooting tool if you're starting to notice that pressure is dropping. You don't have to cut in a new valve, which I'm not a good digger, so that's not my strong suit. You can just switch nozzles over to MP rotators as a first go and see if that gives you that pressure loss drop that you need to get that pressure back up. So that's our standard family. We have since added our MP 800 family, where the 8 stands for a 0.8 inch per hour precip rate. So it's actually double the precip of these guys. So if you run into water window situations with our standard ones, we have a solution for that now. So we can go as low as 6 feet with our short radius MP rotator, who's done really well here in more like California landscapes are getting smaller kind of areas. And then we've now added our MP 815, who's my new favorite. The 2000 used to be my favorite. 815 is my new favorite, because he basically puts water down like an MP 1000, but it's double the flow. So he goes 15 feet out of the bag with a 0.8 inch per hour precip rate instead of the MP 1000, which is a 0.4. So if you haven't seen one of those, they're really pretty. I know it's kind of weird to say about sprinklers, but
No, it isn't.
I'm glad you say that. Some folks come in and they just want to see the pretty streams of the MP, and hey, whatever works, man. So that's what we've got for our MP lineup. And then we also have our side strip models, and these can match either or depending on how you do your layout. So if you have a single row shooting away from a building, for example, you'll have that lower precip rate. Same if you've got more triangular spacing. But if you double it up for rectangular spacing for that added coverage, then you have a higher precip that matches our MP family. So they do match either or. Usually they're zoned separately anyway, but we get that question a lot. So I know you're here for controllers, but I had to do an MP pitch. Thank you guys very much.
Thank you.
It's fun. It's what I talk about every day. So any questions before we go out on the production line? All right, I'm gonna put my little headset on so you can hear me when we're out there, and then we're gonna where we're machining some of our own metal parts. So when we acquired the empty rotator from Nelson, Walla, assembly machine. Each assembly machine is made of different cells. It looks like a lot, but it's easy with time. As capacity was growing, we had to increase our assembly basically. So we added a third machine that was exactly like the old machine. And those can make about 6,000 empty rotators per 8-hour shift on a solid day. That's like super efficient, but that's where we've out maxed out. So those are doing great, but we kept needing to increase capacity. Even going pre-COVID, we had to increase capacity. So the last couple of years was just even wilder than that. So we added our IP4, which is behind me. We named them 1, 2, 3, 4. We're very, very creative, but it's allowed us to just know which one we're talking about. And this guy behind me can make double. So he can make about 12,000 empty rotators per 8-hour shift. So it's pretty awesome. During the height of demand, we were building up to 400,000 empty rotators a week. And you guys were still screaming for product. It was wild. At that point, we just had to throw more man hours and everything. Our mold machines were running 24/7 for over a year. Our assembly equipment was also running 24/7, and we had to pick a weekend a month where everybody got to take a break. I mean, it was wild. And the folks here did a really good job. So now we're running at about 320,000 a week. It's still a lot, but it's not as crazy as it was before, which everybody appreciates. The equipment appreciates having a little bit of a break sometimes too. So we're going to walk around this one. It looks like they might be working on it, but it's more of a linear line. We don't have to do this line, but we'll walk through some of our older equipment too. Half the machine makes our rotor assembly up top, and half the machine makes the canister assembly. So your rotor piece is the only rotating piece on the empty rotator when water is actually running through it. And that's made on this half, canisters on that half, and then they come together in the middle, Willy Wonka style, and they pop out beautiful little empty rotators. If you do stick your arm in it, it's going to stop it. It's okay. They'll just give you, live, so you'll be alright. If you accidentally push any buttons, that's when we have to take you out of here. We've had dad fixing it when someone's in an emergency stop, and now we're out there. So don't lean on anything. But feel free to take a look. If your hand goes through, it's going to turn off.
Yeah, that won't be me.
So we're walking a little bit backwards. The silicone is inserted into the empty rotator when it's rotating like that, and then those rotors come into the center. The center spins really, really fast. Takes out any air bubbles out of that silicone. It also puts that silicone down in a nice consistent pattern around that rotor. And so that's how you get that nice consistent. So the vat of silicone actually behind you. You're not quite finished, and I guess it's the center of the driver's that is very, very right here, you'll see, I'll get out of the way too. Silicone gets injected into the empty rotator. The batter gets pressed down, and then it goes to the centrifuge for it to even out.
I don't want to go in too fast.
So we're also now, we'll go see it in the other room, but we're now making our own statters. There are 4 statters above all empty rotators, so you don't need that flow going through the empty. And we're now also machining some of these. So it's been really fun for the engineering team and our automation team to get good at This is our little nozzle and deflector piece. Talked about an MP3000, the tolerances might be a little wider. If you look at the flows on an MP1000 or an MP800 SR, they basically could be considered time for spring. At one point in California during one of the last droughts we had, folks were asking for us to make them like this. In other parts of the world, they're called rotors. So anywhere from a microspray up to a 35 pretty cool. This is that nozzle deflector piece when combined that creates a flow inside the empty. The tolerances are really tight and our quality and engineering department. Going down. You'll notice we have a spring winder here as well. The reason for that is anytime you've got a spring in a product, try to have it created on the assembly line. Otherwise, this is that tight. You end up getting a box of wound up springs, and this isn't something that you have unwind to load and put it out of assembly. So there's a spring inside the empty rotator. It's a little bit harder than you can watch it if you want to look at it. And that spring allows the empty rotator to have that double pop feature that we talked about in our marketing material. So as the riser pops up, the MP stays nice and closed until you get just a little bit higher pressure than that riser, and then the MP opens up. The MP then closes before the riser retracts as well. That's kind of lost in slow speed. When it's happening in real time, it's hard to tell, but in slow speed, the MP rotator stays closed until that riser is fully popped up. And that's where that spring comes in. So the spring is wound over here. I have to stop for a little view and shot over to the MP rotator goes for a little bit. Sub-assemblies and final assemblies. So it's important to make sure the individual parts are good, but we also take samples off the line, make sure the sub-assemblies are doing well, measurement-wise, and then once the product is complete, bring it over here to the final assembly. The things that we test for with the empty rotator is different speeds of rotation, making sure we fall within our tolerance range for what we call SOR. We also test it for flow, make sure we're taking this test is more of a stress test, so we're going to run the empty rotator and get a finer test.
Might get a little wet though.
That's okay. The phone can handle it. That's just mesmerizing.
It is.
site for us. So invested in this cleaning washing machine for brass tips. We can also recuperate some of the oil that was used in the machining process using this machine, as well as attaching it after the fact. And we sell it back to our brass suppliers. The oil we can also recycle as well. So we can go time, but we can also use Is he gonna fall in or not? I don't know.
Somebody will get 11.
Somebody might get 11. Lucky, right? Maybe it'll be you. I don't know. But it's fun to watch. And what's cool about the project is it's a completely designed model. So we have it on a weekly. Typically for our bigger equipment, like full-on assembly, we have designers on site, but we work really closely with vendors to build those big pieces of equipment. So this is fun to be able to bring in-house and do 100% ourselves.
That's the best way to do it. Make it yourself.
It's fun, yeah. I'm glad it's running. They've been running the bagger and on second and third shift, building mostly first and second, bagging on second and third. So a lot of the tours the last few weeks haven't had the opportunity to see our lovely bagger.
Well, the MP rotator part of this was really fun. You got to see all the machines working. You got to see how they load the nozzles into the bags, which was actually my favorite machine. That one looked the coolest. Now we're going over to a testing facility. Let's see what they got for us over there.
You guys go ahead and put them up. Come on in. Welcome to our spray lab. Yeah, we like to video it quite a bit. So come on in, leave room for your buddies. Come on in. Don't be shy. We'll take up the room. Of course, this will be getting bigger, so we're just taking up the whole room. It's all good. I'm just gonna yell at you guys in here. So if you can't hear me, I'll put the headset back on, but I kind of like to yell at you. So welcome to our spray lab. This is where we test MP rotators for audit purposes after they're assembled. Really, this room was developed for our spray nozzles. So back in I'm gonna just put out a guess, 2005-ish or so. Jamie can correct me. Oh, I made stuff up right. Yeah, so back in 2005 is when we built this test stand because we were redesigning our pro adjustable nozzles at the time. So instead of just finding a nice warm piece of cement outside where you can put a nozzle on, maybe have a flow gauge if you're lucky, we can actually quantify the performance of our spray nozzles in our spray lab. So that's why this test stand does only come out 20 feet. This is pre-MP rotator days. We have 714 catchments, each one spaced 1 foot apart, and each one tells us how much water falls inside each catchment. So this is where we collect our catalog data. We can do densogram data in here to test our DUs, which are really important, especially as we get into MP rotators. We've got high uniformity out of the MP. So anytime we're touching molds, we want to make sure we haven't messed with that high uniformity expected of the MP rotator. So here we've got an MP 2000. It's running at 30 PSI, so it's only going about 17 feet instead of that full 19 to 20. I like showing off the MP 2000 because it did used to be my favorite, and it also just takes up the room really nicely. You're welcome to go back there if you want to play with it, or you don't have to. This is your time, whatever you guys want to do. But I like showing this one too because you can see the different streams that come out of the MP rotator really easily. So you've got your close-in coverage with more of a wiper stream. You've got your mid-range streams coming out of the MP, and then your long-distance, higher trajectory stream out of the MP rotator. So these put water down like a rotor. Puts water down really, really slowly. Rotors do too. It's using that stream technology, which also helps against wind, things like that. Spray nozzles are still a great product. We're happy to sell them. We're happy to make them, but we're just also pushing more towards this higher efficiency type product. We're seeing the industry go this way, so we're also going this way. Can we switch it over to the 816? Thank you, Jamie. Jamie's amazing. Everybody say hi, Jamie. Don't all speak at once. All right. So Jamie helps out in here. He's one of our main test technicians who's testing spray nozzles, and he helps me with tours. So otherwise I'm running. So the way this test stand works is the first minute and a half, the pressure is going to fluctuate. So don't look at it. The MP is gonna start off really slow and then it's gonna speed up, so don't get too scared. It's gonna then settle after a minute and a half, and we collect data for 5 minutes after that. And that's how we run all of our spray nozzles and all of our MPs. And if we want to test an MP rotator that goes beyond the 20 feet, then we can put them in the corner test stand over there, or we can test him up in our rotor test lab as well. So this is that 815. I just want to make sure you guys see it since you're visiting the factory. It's our newest MP rotator. It's been out several years now, but I think with COVID we kind of lost a lot of information, and then it's also kind of hard sometimes to get that new product out. So this is that newer MP rotator. If you're interested in putting water down a little bit faster, if you're not, totally cool too. But just want to make sure you're aware that we do offer this now too.
What was the preset on this one?
This is a 0.8, yeah, so it's double that of a double the MP 1000. You'll notice the trajectory is a lot lower too. So if you're using it to, if you're used to MPs throwing over plants or something, this is not the MP rotator for you. This is good for turf grass and other crawler type lower plant
Or high wind
material.
areas.
High wind areas for sure, yeah. So just want to make sure while you're here you got a chance to see it, because this is my new favorite. And you're welcome to walk back there if you like. We are getting close to time, so I'm going to burst test a pro spray for you real quick and then send you on your way. Because if you come to the factory, we get to blow stuff up together. Are rated to 100 PSI. Anyone want to take a guess at what pressure they actually break? 120, 200, 150,
400.
400, I like it.
I'd say over 6.
Over 6. Man, you're pushing it today. We'll see if we can meet your expectations. And then the other thing we like to test, not part of our normal quality check, but when we're doing this demo for folks visiting, we like to loosen that cap half a turn. And in this, we're just going to demonstrate if you've got temperature fluctuations over time, plastics kind of loosen, that you don't end up with a cap to body leak with the pro spray, even with a loose cap at really high pressure. So come on down, take a look. Oh, that little dot is the plastic injection point. I'll pass it around. So that's where the plastic's injected into the body. It wraps around and forms what we call a knit line or a seam on the other side. So it always breaks in the same location. You'll also notice that that cap never leaked, and that's just the beauty of the pro spray. Yeah. So we'll start over here. I'm going to do over here so you can watch it.